Example 3 says create a table of values for y equals log 2 of x. I'll give you questions for homework for both questions 2 and 3 at the same time. Create a table of values for log 2 of x. Well, when you see log 2 of x, that's a basic log graph. Immediately you should think of this shape with this asymptote. And you can label 2 points quickly. You know that it's going to have 1, 0 and 2, 1. So as far as starting your table of values, you know that when x is 1, y is 0. When x is 2, y is 1. What would be the next nice point that you would plug in? 3 doesn't give us a nice answer. 4, what is log 2 of 4? 2. What's the next one? 8. Log 2 of 8 is 3. So the table of values here is just really asking yourself, do you understand what a log is asking for? A log is asking for the exponent. Right? When I have log 2 of 8, I'm asking 2 to what power or what exponent would be 8. And then I can figure out that that would be 3. So there's our table of values. Well, how is the graph of y equals log base 2 of 2x minus 1 related to that graph? Well, we've been graphing these now the last little bit, so we could graph this easily. I'm going to actually not sketch them on the same grid. I'm going to sketch this one on its own. Okay? First thing that you need to realize that this 2, that's part of your parent graph. So it's not going to affect any transformations. As we're going from left to right, the first number that affects our transformations is right there. That's going to be horizontal compression. You're going to multiply your x values by 1/2. And this 1, is that inside the function or outside of the function? It's outside. If they wanted that minus 1 to be inside the function, they would have to put brackets around there. But there are no brackets, so that is a vertical translation 1 down. So we could take our original points, which are 1, 0 and 2, 1, and going from left to right, dealing with our stretches and compressions. First, we're going to multiply x by 1/2. So we'll have 1/2, 0 and 1, 1. And then we're going to move 1 down. If we look at our asymptote, the only way your asymptote's going to change is if you move things left and right. So in this case, it doesn't change. It's still going to be at x equals 0. So taking those points, start with our asymptote, which stays at x equals 0. Plug our points in. So we now have 1, 0 and 1/2, -1, and draw the shape of your graph. So your questions for homework are 7a. Did I answer all the questions? Identify the intercepts. So we need to write the intercept. It only has an x-intercept at 1. What else did we need to say? Equation of the asymptote, domain, and range. So the equation of our asymptote is still x equals 0. The domain, x values are bigger than 0, and our range is everything. So our questions are 7a, 8, 9, 10, and 11. We're going to work on these for the rest of the class. If you would like to do your graphs on the whiteboards instead of in your notes, you can.
The office, Mr. Aman Mathieu, please contact the office.